Hi guys, in this video we're going to talk about the law of conservation of mass, and I'm going to be writing on some Cornell paper, so make sure you have some of that. Here's mine. Now remember, you want to fill this out right here with your name, class period, and date, and our objective is conservation of mass. That's objective 4 for unit 1. Let's get our essential question up. How do I apply the law of conservation of mass? Okay, so in order for us to be able to do this one, we need to know what the law of conservation of mass says, and then we're going to apply it. And we will talk about those activities we did in the lab. So let's take a look at how you write it to begin with. So the law of conservation of mass says that in a closed system, the total mass remains constant. So what this means is that you can't create or destroy it. You've probably heard that one when we talk about the conservation of energy in physics first, a long time ago. But you can't create or destroy mass either, and the total amount remains the same. So how would you find the total? How do you find the total mass? Well, you just add it all up. That's pretty easy, right? So when we're thinking about the total mass, we're saying that however much mass we had before is going to be the same as the mass we had after. So let's take a look at what that's going to look like in a couple of our lab scenarios. So part 1, we did the pulling apart of steel wool. In that one, we saw some really tiny changes, tiny changes. We didn't really notice, it wasn't a whole lot. So what we saw was that mass was conserved. Those tiny little changes were actually probably those little pieces falling off, but we saw that mass was constant. And if we had carefully swept up all of those little pieces and put them all back on the scale, or maybe tried to do it over the scale so that all the little pieces that fell off landed there too, we would have found that the mass was exactly the same. So the before mass and the after mass was the same. So the second one was melting ice. And that one, we also saw that mass was constant. We did see, again, some small changes because some people had their water get a little bit warm and it started evaporating. We saw some steam coming off every now and then, but if we had put a lid on top, none of that would have been able to have left, and so we would have seen that mass was constant also. The third one that we looked at was dissolving sugar, and in that one we also saw that mass was constant. We did have a couple of people who must have forgotten to measure something before or after, because we did see one or two really big changes, but again, that one is dependent on whether or not you had everything on the balance. So in these, mass was constant. Any little bits of change would have been due to some sources of error, but otherwise the total mass stayed the same. If we had been very careful, we would have seen the mass stay exactly the same. So I'm going to flip to my next page. There it is. And we're going to talk about the next one, which was, let's see, number 4, forming a precipitate. And in that one, we mixed the two clear liquids together in the test tube, and we found that mass was also constant. We had the same mass before as we did after. Any small changes in the mass were probably due to a little bit of the liquid sticking to the stir rod when you mixed it. There was one that was a really big change, but I bet that person forgot to put a test tube on the balance or something along those lines. So we saw that mass was in fact the same there. The next one, number 5, burning steel wool. This one was the most exciting one because despite the fact that we saw little pieces falling off, we measured it again and the mass had increased. That's a huge deal. Mass increased. If we had been able to sweep up all those little pieces that had fallen off and put them on the balance, we would have seen an increase even more, which is mind-blowing, right? Well, where did that mass come from? We'll make a little note here. The mass that we saw here, that increased in the mass, in the discussions that we had in class, we decided that it must have come from the air, so the extra mass. The extra mass must have come from the air, and the other important thing to note is that because it came from the air and we didn't have a sealed container where we were able to measure this, this was not a closed system. This was an open system. Air was able to come in and out of the system, and we weren't able to measure it beforehand. If we had been able to measure it beforehand, if we had been able to measure all of the air that ended up sticking to the steel wool, we would have seen that the mass stayed the same, but we can't really do that. Measuring air is pretty difficult. So we saw the mass change instead. On the last one, a similar problem. In the Alka-Seltzer and water lab, we saw instead of the mass increasing or staying the same, we saw that mass decreased. But if you remember what it looked like when we put the Alka-Seltzer in water, we had little bubbles forming, and then those little bubbles were popping. So what was really happening was that that lost mass went into the air. And just like in the last one, we had mass that was able to leave the system this time. In the burning of the steel wool, mass entered the system. This is also not a closed system. This is an open system. In an open system, sometimes we see mass changing because the mass is able to come in and leave as it needs to. In a closed system, all that mass is trapped in there. You're not adding anything new, you're measuring it all beforehand or afterhand, and so the mass is able to remain constant. So closed system, mass is conserved. Open system, mass is not conserved. So what we really had, if we think about it, we had two open systems. Here we go, two open systems, and then we had four relatively closed systems. Now in the first four, the pulling apart the steel wool, dissolving sugar, melting ice, and forming a precipitate, those were technically open systems, but the mass wasn't a gas. That gas wasn't there to leave, so that didn't happen. So the law of conservation of mass doesn't change. That's just how it is. Make sure you write your questions and your summary in order to get full credit for the notes. Thanks for watching.